Sorry, which proposal is this?
Mike has a proposal so we've been looking at various storage solutions, and one thing that's very clear is that we have to make a distinction between the storage verb and the send verb in order to charge appropriately. So we are looking at a couple of different ways to do that, and Mike proposed one way, which was to have a special shard in which the storage contracts are whitelisted, and there's not much else you can do there. Nothing else is allowed apart from the supporting infrastructure for the storage contracts.
One thing I don't like about that proposal is it seems like it kind of defeats the purpose of storing things on chain in a certain sense. Like, for example, the R song wouldn't work very well with it because you couldn't have the contracts that also, does whatever with the royalties, right? Because if you're limited to only things that deal with storage and updating storage and nothing else, it seems like you can't do any other on-chain computations that might be useful. So in some sense, you can't use the data for anything other than having it on-chain.
Well, you'd have to have a cross-shard contract, right? So you'd go up in the tree for those computations. That would be my understanding.
But cross-shard we've established is pretty expensive, so I don't know. It seems like it makes everything like if storage if the point of this is to make storage feasible, I don't necessarily think it does. If you sort of move all that cost onto, now it costs you an arm and a leg to actually do anything with your data.
That's a good point. So that's a nice observation. Good. Yeah. So if the cross shard calculations are prohibitively expensive, then this is not a solution.
Sorry, I'm out of the loop, but why can't you just have contracts store things themselves on their own chart that they're on?
You can. The question is, how do you charge for it appropriately?
So, sorry, I was going to ask, is there what's the, I'm assuming there's some complexity there that I'm not seeing just because due to the kind of rolling model, I guess?
No, if you look at Ethereum, you end up paying the cost all up front, right? And
yeah,
that means it's completely unfeasible to store, for example, a song. Nobody's going to pay $10,000 to store a song. Even if you cut it by 1/10, nobody's going to store a song for $1,000. What they'd rather do is to amortize the cost and pay it over time, right? So rent is a more reasonable approach in terms of adoption, right? And
I see.
Yeah. So now, in order to do that, you really need to disambiguate. When you get to the nuts and bolts, you need to disambiguate when you're doing a write. So effectively that like in the rolling model, this is sending on a name versus when you're storing.
I see.
Yeah. And you basically you have to mark the two different intentions so you can charge for it appropriately.
I gotcha. Okay, so is the point that storing and sending on a name in rolling essentially look equivalent unless you purposefully mark them?
Exactly so, yes.
Gotcha. Cool. Okay, cool. Makes sense.
Yeah.
So I guess my next question would be, what's the disadvantage just from having people do that? Imagine if people did essentially have to declare, whenever they made a send, whether they were storing or sending. Why couldn't they do that on any shard that they were on?
Well, in fact, this is a second proposal. 2 weeks ago, Mike and Meta and I had met, And we came to the conclusion that in order to store appropriately, you do have to mark them. And at the time, Mike was going to look at costing out the language change so that we actually had a store verb in the language. And then he sort of thought about this other idea as maybe a cheaper way to get there in the Mercury timeframe. And so I said, well, let's make sure that we run. Actually, I think there's some advantages. If it weren't for the fact that cross shard computation is a tad on the expensive side, I like his proposal because it's very much in alignment with what we've been thinking. Is that there are going to be special purpose shards where you end up with the special purpose compute capabilities from one shard to the next.
I see. So pretty much at this point, the main benefit of storage only shard is just that, excuse me, the complexity is like much less in terms of student release.
That's right. That's it. Yeah.
Oh, Vlad just joined.
You, Vlad?
He's on the chat. He put something in the chat.
Hey everyone. How's it going?
Hey, Vlad.
I'm in a tunnel right now, so it's a bit loud, but I can see it. I'm going to go quiet. So I kind of missed the proposal for the storage shard. Is the idea that like the storage is only going to happen on the storage shard, or is it just like a shard only storage?
It's a shard for storage. So basically, it's contrasting it against a language change to Rolang, where you mark the storage verb as distinct from just a send.
Okay, but you can store processes in Rolang in any shard, right?
Yes, you can send processes. The point is that what distinguishes storage from just a send is the cost model, effectively. When you declare your intent to store, you're saying something about how you want to pay for it. And that's
why is storing lookup term different than the cost model of storing some random data?
Well, again, the point I was making to Nate earlier was that we are it's not useful in terms of adoption to pay for the data all up front. What people really want to do is they want to amortize the cost of the data. They effectively want to pay rent. So you need to know that this is in fact what you're doing, or that's what the intent of the right action is, in order to charge for it appropriately. So that's the basic idea. If you look at it from the process algebraic perspective, or if you look at it from the special K analytic framework that I outlined some years ago, storage really is different. Storage really, it says that read does not consume data. So you can actually disambiguate it mathematically. When you do, like in a normal send, the read consumes the data. So in a storage situation, the read doesn't consume the data, or alternatively, there's another process which puts the data back after the read. So you can clearly see that there's different activity, and one needs a way to express the intent so that you can amortize the cost.
Okay, well, anyways, I'm satisfied. Although I think I don't understand why it would be a change to row count. It seems just like a row laying change, right?
It's a row lang change, not a change to row
Oh,
count.
okay. Oh, okay. So that doesn't seem like, I don't know why it's preferable. I mean, a row laying change. Oh, because you wanted the virtual machine to be aware of the fact that it's storage. Because actually, it would have to be a row count change also, because otherwise, how will it be?
No, it's not a row calc change. It could be
But otherwise, how would you price it differently?
Because in the row calculus, it's literally implemented differently. In the row calculus, you can see that it's different because a send is consumed by a read. In order to make it a store, you have to put it back. So you have to write extra process behavior.
Oh, okay. So it's not a change because that information is already there.
Right. It's not a change to the calculus level. It's a change to the language level and what you do with the implementation of that language directive.
Okay. But anyways, I guess I'm pretty satisfied and happy to move on from this topic at this point.
Cool. Meta, we were going to talk about one other thing.
Here.
It was I was calling it cost model, but it wasn't cost model. It was
Did you want to run the cost accounting change by? No.
no, it wasn't cost accounting. It was something else that was related to cost. Darn it.
I have Mateusz here. Let me ask him quickly, one moment.
Okay.
It seems like the storage shard may be a non-starter due to the royalty contracts having to be cross-shard.
I think that's probably true. So I think the language is the language change is the simplest change.
What is this royalty contract cross-shard? Sorry, what's that?
So what we were doing was looking at a sample application like RSong, right? In RSong, there's an additional contract that sends royalties out to the contributors named in the metadata as participating in the content. So that contract would be forced to be cross-shard because in Mike's proposal, that contract couldn't live in the storage shard.
Okay, but the contract, but you can have storage and a little more room. I mean, I see.
Yeah, so now what you're talking about is that for each use of storage, you'd have to add a little extra contract. And now it's no longer a storage shard. It's just like, storage plus local access. And then the line gets incredibly blurry. And it feels like a cleaner change is going to be at the language level. And in part because then you can do analysis at the language level. Right? You can get the compiler involved. Did you really mean to store here? Because the consequence will be blah.
Greg, if we take the language approach, is it going to be a hard fork when we implement storage? Can we do it after Mercury? I don't know that the sizing I got back for that work was fairly large, which is one of the reasons why Mike came back with this shard proposal.
Okay, let's take that discussion offline.
Okay.
Cool. Well, maybe that's it for us. Nate, Vlad, Michael, do you have anything else?
Yeah, I mean, I have a bunch of updates. I'm not sure. Nate, have you given any updates yet?
Not yet, no.
You want to go for it? I feel like I want to, take the rest of the time once I get on.
Sure. Yeah, I'm happy to go. So slowly getting back into things. I spent the last week doing some work on the safety oracle. You guys might remember we had a bunch of problems with our last safety oracle and then thought we figured it out. And I'm like in the process of starting to formalize like our newest version, I guess. Mostly at this point, like re-familiarizing with our old problems and kind of working through the same stuff again, but slowly making progress towards like an actual working version that we think we have, like, you know, with full formality, I guess. So hopefully by next week we'll have something more concrete to share, but cool. That's it for me.
Michael, Gary?
Nothing in particular. I have been doing mostly implementation stuff on the RChain side. I guess the most interesting chat people recently had was about the joining fees that a new validator pays to existing validators when they join. And so I implemented what was in the spec, and then there was some pushback against that about, you know, maybe the distribution of that fee to the existing validators is too steep and so on. But I don't know if we want to actually hash any of that out here.
Yeah, I mean, I feel like we should have like another validator economics call, and like the please vote for that.
Yeah, no, I agree. Yeah.
Or, you know, I mean, one idea that I kind of had when Kent messaged me about this is that you guys could run a test, right? Like, imagine, you know, like doing a test if people are playing for sport or for some rocks, just to see what strategic behavior arises and how people feel about the fairness, et cetera, of the situation.
Yeah, there are plans to have incentivized testing, so totally, we'll end up doing something like that.
So that was, in fact, the thing I wanted to talk about. Meta was exactly this: the joining fees. Yeah, I mean, I was thinking that we could kind of get the best of both worlds. Like Mike was pretty adamant that the joining fee growth curve has to have a certain characteristic, and Vlad was concerned that the randomization in joining would make the deltas that you get these big deltas that weren't meaningful relative to the actual joining. And so I thought there might be, sorry, I meant Kent. Yeah. Kent was arguing that these like accidental reorderings in joining would result in big deltas in joining fees. And I thought that, you know, there might be some kind of time bucket approach where if you join within a particular window of time, then there isn't such a big delta. So it's only it's only, you know, from bucket to bucket that you get this growth that Mike was advocating for. Does that make sense, Michael?
Yeah, we could do something like that. So basically, you keep the current distribution function, but instead of ordering validators 1 through n, you order time buckets 1 through m, and there's some division there someplace. I feel like there's some work to do there in terms of what the logic actually looks like. You know, if I get validators joining sort of every, like, I guess where do you put the cutoffs and this sort of thing? And like, if you just end up on the wrong side of a cutoff, do we still end up with the same problem? And anyways.
Yeah, understood. Yeah. I mean, I think there's always going to be some kind of grumbling somewhere.
Yeah,
you know, but I think that like there's much more grumbling when you do fee distribution than when you have fees than when you just don't have fees or fee distribution. Like if we didn't have fees and fee redistribution, I think there would be much less grumbling.
Yeah, understood.
This is just joining fee distribution, not transaction fee distribution.
Yeah, just joining fees. Yeah, that's right.
Yeah.
Vlad doesn't like joining fees.
Of course not. They're barriers to entry, which means that it's going to reduce the security of the system. like full stop. But they do increase the profitability. They do increase the profitability of incumbents. Sorry, I'm not sure if I broke up or just no one said anything.
I think no one said anything. I heard you at least.
Yeah,
Okay.
I heard you, Vlad. I understand your argument for sure.
Okay, great. Well, in that case, maybe I can give some updates if we're satisfied with that conversation.
Cool.
Well, I missed the last couple of hangouts or stand-ups, so I have a bunch of updates. So the biggest one, I guess, is that I've been at East Berlin, and like the following week, I worked on the implementation of the chartered folk choice rule that we came up with during the IC3 bootcamp, which has this like weakest notion that we know about of atomicity, that basically like we can't finalize an atomicity failure. And we integrated over the Ethereum virtual machine and are sending like ether back and forth across the shards. And we have like a visualization that like displays everything. And it was pretty cool because like, it only took a week and, or it really took a couple of days to implement core components. And then I spent a week just fixing bugs and, just making things like, run and be pretty. Like fixing the integrations and it was quite a cool experience because, I got to actually, I found a couple of conditions that were missing from my definition. And, it's like a little proof that like the starter for choice rule thing, works really smoothly, even under like, and it's like one of those things where like, okay, you don't really know like how the performance is going to be, like how many blocks are going to be open.
Hello?
Fixed shard configuration and a routing system for multiple shard configuration for dynamic shard configuration so that the routing tables get updated. It's very different from when we have a fixed shard configuration. Because with fixed shard configuration, you can use source routing. And so I have basically a pretty cool, super simple sharding, super simple routing protocol for the dynamic shards, where essentially every node keeps track of enough information to make the decision of whether to pass a message to the parent or which of its children to pass the message to. By node, I mean shard. Every shard has like a single parent at most, and can have multiple children. And so when it has like a message that's like on the way to another shard or to an account on some shard, it just needs to know like which single hop direction to pass it, and basically like these tables that kind of show which of the names are under the children of a node, so that I can tell whether to pass it to those children. And if the name isn't under the children or under the third shard, then I pass it to the parents. And it's pretty easy to show that this routing system gets messages to their destination even during the shard location changes, because like every time in the same operation that I change shard locations, I can update the tables so that they're necessarily consistent with any correlation. And so that basically gives me pretty much a spec for arbitrary changes in shard layout and routing for many shard functions. And then the next kind of part for me is to come up with a spec for the load balancing algorithm. But my plan is to at equal stuff next week, implement the routing algorithm and the dynamic shard rotation. So if anyone's listening to this and it's going to be an ESF and wants to help pack, definitely looking for help because I don't want to do all the work myself. There's going to be a bunch of work to do, including implementing the data structures and visualizing them and integrating with the with virtual machine integration to be a little bit more involved because I guess not quite. Well, I guess there's be changes to the messages. There's gonna be a bunch of changes that need to be made to the existing threading implementation I have. I just put the concept. That's like one of the main things that I've been working on. I've also been working on the kind of light client stuff with the DM. Basically trying to come up with a light client. Looks like not. We're going to come up with a light client spec where everything from like a full archival node and like the lightest possible light client are possible protocol states, so that we can preserve all of the CDC Casper stuff via computer states because allowing nodes to progress from a light client to a full client to an archival node just by essentially downloading more of the dependencies of the messages. And so we're going to have hopefully pretty soon spec for basically the light client version of CDC Casper, which I'm optimistic will be sufficient for our starting needs. In that, like if I implement the starting protocol with these like tunable light clients, then it should be completely possible for the nodes to like specifically have nodes that only follow and show on different charts. So yeah, hey Nate.
Sorry, quick question. Can I ask a question about the light client protocol?
Yeah, of course.
So do nodes, so essentially you're a light client, you're downloading lots of dependencies. Are nodes still necessarily able to kind of check all equivocations that they need to?
So that's a good question.
You're muted. I'm assuming you got noisy.
Yeah, there was a car going by and it was like incredibly noisy. So I mean, definitely, if you download every message header, absolutely you'll be able to check the equivocations. I'm just like trying to think through if you need to. And I think that like probably you will, but there's another option, which is the one I'm kind of considering, for like the extent to which we can land message.
Sorry, I'm having trouble hearing. There's a.
Let me just wait a second for the announcer to stop.
No worries. Sounds good.
Okay, well, it seems like it's already stopped. So the main question that I have is the extent to which we can back off of message validity to save on the work of making sure that you're not accepting too many equivocations. But definitely, if you just look at the headers, like it'll be enough to check for our equivocation. So, like the answer, my quick answer is like yes, even the lightest clients can see all the equivocations. However, you've challenged me now to even save on more of this overhead for checking the equivocations. But definitely it's definitely consideration and a good question. But definitely like that, the idea is headers only, and absolutely you can check equivocation headers.
Yeah, cool. Yeah, okay. I'd love to see. It'd be cool if there would be a way to check equivocation with less than all of the headers.
Well, I mean, so the with sharding, it's going to be a little bit better because you're not going to look at all the headers and all the shards because you're not really interested in all that. I am not sure, but it would be definitely cool. At the moment, I kind of, but I don't feel like I have a proof yet. But one of those things where I have to just wait for it.
Cool. Thanks.
No problem. Yeah. Another thing that I did is I've been working on blockchain governance stuff for the last couple of weeks. I hosted a blockchain governance workshop and published my Governance 101 blog post finally, which I hope you guys all read, and which I think provides like a pretty okay summary of the governance challenges that we have, in the whole blockchain space and Archain inclusive and Ethereum, basically everyone. Literally everyone. 1 second here. Hey, sorry about that. So there's like another car going by. So the other thing that I've been working on is the economics stuff. Basically trying to do, and well, I think successfully doing cost of attack maximization. In preparation basically for the workshop, the crypto economics workshop that we're going to be hosting at DevCon. And so the process here is, something that we've talked about before, but you kind of express the game, figure out the equilibrium of the game, and then figure out the cost to an attacker to change the equilibrium or to make the equilibrium some kind of failure equilibrium. So you specify an attacker, and then basically from just analysis of game theory, we can kind of see that what cost is equilibrium. And we kind of want to do this also in the context of lots of different kinds of behavioral models. And so I've been working with Giorgio on coming up with definitions of stability and robustness and persistence that are parametric in a notion of deviation, as opposed to always kind of building everything in terms of match equilibrium or some particular given equilibrium and having to redefine stuff. So ideally, we'd just have all of the notions in our economic toolkit be parametric in a notion of deviation. The thing that we've I think plainly succeeded in doing is quite easy to do is the definition of stability, which is because it's basically a fixed point under the notion of deviation for any of the agents or sets of agents. So the notion of robustness is also quite easy if we're just talking about the getting rid of an equilibrium, because it's just getting rid of the fixed point. The one that's challenging is the notion of persistence, which has to do with the idea that if an attacker pushes the players to play a strategy that's not the equilibrium strategy, what is the question is, will it return to equilibrium? And the initial definition of persistence that I had actually turns out was more like plausible liveness than liveness. So it wasn't that I was saying that I was just saying that it was possible to return to equilibrium, as opposed to that it's inevitable or likely, or something like that, which is a little bit of a more compelling argument that the system is persistent. So I think that's the main updates I have. Kind of a few weeks of updates packed into 10, 15 minutes. Feels a little weird. Do you guys have any questions about any of this stuff?
Quick question about the last one. So the last update, the economics one. So for this persistence thing, are you essentially talking about if the attacker stops attacking, we'll go back to the equilibrium that we want, or is it?
Exactly. That's exactly it.
Okay, cool. So is it a question of do you think about repeated games, or are you just saying alternative thing?
That's right. I'm taking that repeated games.
Okay, cool. Are all of these kind of definitions and things you're thinking about independent of the representation of the games that you're thinking about? So do all these things apply to normal form games and iterated games, et cetera, or is it for one specific one these definitions fit?
Well, I think it's definitely for definitely the persistence is only makes sense for iterated games. So I think all the other ones make sense for all the games. Because I mean, I think all the other stuff I'm pretty sure makes sense in all games. But whereas persistence requires this idea that we can have something happen and then have the system recover, which means that there has to be multiple time steps at least. So it's not a simultaneous game definition.
Cool, makes sense.
Someone else maybe had a question. I remember I felt like I heard someone saying something on the church feed. Anyways, so that's mostly my updates. I'm really excited about the sharding stuff. I'm excited about. Also, I'm becoming somewhat more optimistic about the non-hierarchical sharding, because I am getting this intuition that we could definitely make a system that will have finality. It's just the determination of safety that is the challenge. I think stability is not actually going to be the issue. I think we're going to have fixed points. I think the detection of those fixed points is going to be relatively quite hard though, or not as stupidly obvious as the way it's done in the hierarchical consensus.
Cool. Do you think that the same block structures are going to work in both cases? Like, do you think you're going to be able to inherit your sharded block definitions for the non?
Yeah, I think I will, because I think I could even do something. So here's a concept, right? Imagine if each of the shards is running a CDC Casper, say like a friendly ghost, where there's a kind of let's imagine for now a special kind of block, which is the CDC Casper block at level 2. There's the kind of higher, or this is kind of a more, instead of it being hierarchical in the sense that we normally talk about hierarchical sharding, it's more nested in the sense that the shards run consensus protocols, they run consensus protocols, they run consensus protocols. So if all the shards are running a consensus protocol, we could definitely detect safety in that consensus protocol with the safety oracle that we have now, because it's just a friendly ghost. And then the question, and then my instinct is that that consensus protocol will be enough to do the coordination required to finalize stuff for a non-hierarchical sharding system, and essentially these shard blocks, I think these kind of level 2 shard blocks, I think can be. I think I can implement them just as right with the normal block structure without introducing any block type. And the intuition there that I have is basically that we can make it so that every cross shard block is one of these blocks. But definitely, I'm not so concerned about preserving the block structure. If it needs to be changed, that's fine. It's different, because of the kind of methodology, we can make changes rather freely without really worrying about the risks for consensus or anything like that. So I'm pretty excited about that. I do need some significant changes to the block structure in order to do the routing thing. So that's all. All of that stuff is part of the consensus value, right? So definitely, there's going to be changes to the block structure, no question. And I'm pretty excited. I think that I have we're going to be able to. I'm going to be able to have something together that is going to show people and be really helpful for education, and which is going to host the virtual machine without changing it at all, which I'm excited about. I'm excited about not having to change it at all.
Cool.
And also having the validity conditions for the virtual machine execution. Like I think it's like basically it's not going to require any change. Like we're just going to use the kind of Web3 interface as intended for all of this stuff.
Cool stuff.
Yeah, it's exciting. I would say it's like part of the education effort. And then like for me, the hacking is not really a research effort, but I do actually end up. It does end up forcing me to look at stuff, and I did find that like we were missing some conditions, which were pretty obvious in hindsight in our initial starting spec, because of bugs that came up in the implementation. So that is nice and helpful. Even though I don't know that that's entirely research up there. Definitely come and help me hack in San Francisco. You're listening to this every day.
Cool. Any more updates from anyone?
I'm on my way to hanging out with the two level devs now, and so they have some they definitely have some things for me to look at because they've been telling me about it but not wanting to tell me until I get there. So I wonder, another thing that I kind of spent some time thinking about is the whole DOS problem. And basically trying to reason about whether it's okay to just subjectively rate limit the number of messages that you receive from every validator. So that if a validator goes off and makes like 100 messages real quick, you will they're basically going to be like, if they continue going at that rate, you'll never catch up to seeing their messages. But like if they stop, then eventually you'll catch up and see all the messages. And then this like rate limiting will basically be guaranteed to give us a bound on the capacity that a node needs to operate at, which is kind of what we want ultimately for the DOS proof, like a DOS safety proof. What we wanted to say is that it's like impossible that a node will consume more than this amount of gas per second, because basically it just refuses to. And I'm pretty confident that this is all fine for it doesn't factor into the safety issues. The question is basically whether it is going to be a live issue, and that's something that's a little harder for me to answer. But I'm guarding the outcomes.
It seems like it seems like it almost exactly is the liveness strategies that we've been talking about so far. Like ignore messages from people.
Yeah, so it definitely is. It fits in the same language specifying. It seems like it's definitely part of the validator strategies language. Although I would say that if you're just trying to get liveness versus if you're trying to get liveness while not consuming one amount of gas, it's easy. It's like a harder problem to do it while not consuming much gas.
Yeah,
it's implementable by the same kind of validator in the same validator strategy kind of slot.
Cool. Yeah, that's interesting. Yeah, it seems like any other liveness strategy we come up with has to fit within the restriction of and also you can't make more than this many blocks or people will rate limit you. Or something like that.
Or more like all nodes, like any node that's following the protocol. Basically, here's what I want to do. Ultimately, I want to say you can run it on a Raspberry Pi. That's my goal. My goal is that we'll never ever have to go to the big computers.
Interesting. Okay, cool. Yeah, that sounds like a nice goal. I wonder if it's possible, but
I'm sure it's possible. The question is just whether or not people will accept it.
Yeah.
But what I'm saying is I want to be able to say give a bound and tune the protocol like that, and basically I agree there's probably going to be a bound at which It's actually no. Now that I think about it, as long as we're not limited in storage and memory, then I think like we'd be super limited in compute power and like still say that like, oh, they're, for any devices, I could like basically set the bound, and then we have to kind of guarantee that those devices are fast enough to keep up with memory.
Yeah, I guess that seems reasonable. Fair point. Cool. Yeah, it would be nice to be able to like parameterize that. I feel you though.
Yeah, I mean, I think I would go as far as to say that it's necessary for the DOS protection. It's the same tool that's necessary for us to get DOS.
Gotcha.
Have you guys thought again about the DOS and validator strategy stuff?
Not in great detail, but it is something that we are thinking about at least a little bit as we're getting into cost stuff, right? Because cost sort of becomes a de facto DOS protection, right? If you can't crash my node before you run out of gas or flow, then I'm protected. And then as long as I have a network filter that keeps me from taking too much concurrent load, then it's all good.
Yeah, so we basically have, so my philosophy is basically based on like the metering, right? So like, I guess, and that is very highly related to the cost question. Sorry. So I was just saying is like, the metering, is like how I think about how much capacity the code is using. And the metering is also meant to reflect the cost on the node that have actually doing the first thing. So like, the cost of using an opcode or like a particular state transition or rewrite rule should reflect the actual performance or the actual cost on the node to do that.
Hey, sorry guys. I have to run in like a minute. So if there's nothing else, I'll say bye.
Yeah, we got to jump over to Dev Stand-Up, so I'm gonna jump off too. It was good stand-up. I got a lot out of it.
Cool. Thanks for the updates, guys. You're breaking up.